Good afternoon. Thank you for attending my confirmation seminar. The title of my seminar is Quantifying the Seismic and Site Amplification Characteristic of ADELAIDE Regolith. And my supervisors are Professor Mark Jaksa and Professor Michael Griffith. This is the outline of my presentation. I will start from the background and then a discussion about probabilistic seismic hazard analysis for ADELAIDE, and then move to the side effect and preliminary side response analysis that I have done. And after that, I will continue with ambient noise measurement using SPAC method, and followed by seismic soil structure interaction and progress, work to plan, and the last one is proposed paper from my research. This is the background. As we know around us that the numbers of infrastructure of high-rise building has been increased around the ADELAIDE, and according to the Australian standard, ADELAIDE has the highest earthquake threat in the Australian continent. And we may know also that typical building construction in ADELAIDE is similar to that in the Christchurch, New Zealand, which is the building at the New Zealand has bad damage during the Christchurch earthquake. And we also has experienced that the damage of the structure has been influenced by the near surface geological condition. And later on, I will show you also that site amplification also occurs in ADELAIDE. And then I will mention also in my study that noise measurement to study the side effect and some advantages using that method. And I will show you also in the end of my presentation that soil structure interaction is necessary to be carried out in ADELAIDE Regolith. The reason behind that I will explain based on what slide that I explain to you later on. This is that I have mentioned before, based on the Australian standard that Adelaide is the one of the Australian capital city has the highest threat of earthquake. And this is what has happened at the Newcastle earthquake in Australian continent. And I have to say that overall aim of my research is to quantify the site amplification effect of ADELAIDE Regolith on structures that dwell on that particular particular ground surface, which is Regolith. Maybe just to the general audience, Regolith is different with the commonly sediment layer. The regolith is mostly composed by consists of decomposed of rock. This means the bedrock, and then on the above surface in the dewatering of that particular bedrock, which is different with the sediment. The sediment which has been transported to the other places. This means the main sources and the topsoil has been moved to the other place. It's called sediment, but regolith is the surface and the bedrock still at that place. My overall aim to achieve this overall aim, I already break down into some several specific aims, which is consists about 4 different. The first one is to identify the seismotectonic sources. This is important because we want to assess the vulnerability of seismic of any area, we have to know what is the high possibility of earthquake may contribute to the damage of that area. This means the first step have to be done before we proceed to the next step. And then the second aim is to generate the synthetic strong motion. This is also important because there is no time history strong motion in Adelaide at this moment. And the number 3 is to measure the in-situ seismic ferocity in the Adelaide's regolith, which is currently also not available in the literature. And in the end, my aim is to model the behavior of structure that founded into Adelaide's regolith. Significant contribution of my research. The first one is I will generate synthetic time histories for the most considered seismic event for the Adelaide city. And then the second one, I will develop a method for the seismic classes and the regolith environmental, which is currently is not available. And the third one is I will develop a final scale of seismic site classes for the Adelaide city. Currently it's already available, but in a broad scale, 1 by 250,000. This is too big for Adelaide region. And the number 4 is to undertake soil structure analysis of a typical building in Adelaide. List of steps to achieve that one. Some steps that I need to do. The first one is I already mentioned also. I will do the seismic hazard analysis, which is using the probabilistic seismic hazard analysis. This is important to justify the credible seismic event around the Adelaide. And then next need to do is the site response analysis. This is to obtain the seismic parameter at ground level, because in practice, the seismometer is sitting on the hard rock, and we have to know, and the building is not always sitting on the hard rock. Building can be anywhere. That's why site response analysis need to be carried out. And the third one is seismic profiling. This seismic profiling of the ground surface is important to assess the seismic vulnerability, also the size effect. And the last step that we need to do is seismic soil structure interaction to evaluate the seismic impact on structure. Some steps here I already did, and I will explain to you further to the probabilistic seismic hazard analysis incorporating Monte Carlo simulation. The PSHA, the seismic hazard analysis, is currently the most appropriate method to assess the seismic vulnerability of any area, because the seismic hazard analysis can able to determine what is likely the earthquake and from which distance will contribute to the bad damage of any area. And the methodology to do the PSHA in my study, the first one is we have to define the seismic input, which is include A and B value, and also where's the seismic sources. And then after that we have to select the seismotectonic model. In this preliminary PSHA that I have done is I will use the data from Malpas. She was she is a honor student from Flinders University, and that is, I believe that her data is the most comprehensive data about earthquake, and even because she extending some significant earthquake in Adelaide. And this is all the process, and then I have to check or to validate whether my probabilistic seismic hazard analysis is already matched, or to compare with the other using the pseudo-spectral acceleration Regolith and use from the other. And in the end, I will show you also the aggregation seismic analysis for 475, which is correspond to 10% probability of 550 years earthquake being exceeded, and 2,475 years return period, which correspond to 2% being exceeded for 50,000 years, 50 years even. And at the same time also, this PSHA will produce the seismic hazard map for both return period. Why I use the probabilistic using Monte Carlo method in my study? Because there is some reason here, and most important one is this model has been validated using commercialized application such as Easy Freeze and Freeze 88. And if we back to the outline of my methodology, which is define what is the seismic input parameter and so on, I will use 16 zones, which was developed by Malpass in 1991. This 16 zone already cover up 3 most important seismic region across South Australia, which is Adelaide Geosyncline, Eyre Peninsula, and southeast corner of the state. You can see here, it is Adelaide here, and then it is Eyre Peninsula and Adelaide Geosyncline. And the earthquake recurrent parameter, I use Love A. Sinadinovsky 91. He already developed some software to estimate what is the recurrent parameter of each source zone. And the focal depth for the 16 source zone, I use the Malpass 1991. And the overall input of my PSHA can be shown here, which is A and B value is from the Love and Sinadinovsky. The beta and the NO also, this is from the Malpass, and this magnitude from Malpass. But from the depth, this one is I have developed from Malpass. I put wedging here, which is, for example, in the background one, at depth of 10 km, have wedge of 0.5. In total, it's 0.5, 0.25, 0.25 equal to 1. Which is Malpass never put this kind of thing. Put include the wedge, which what the focal depth of the zone. And the result of my seismic risk analysis, which is include the deaggregation. Deaggregation is a process to understand the conditional of probability that contribute to the most severe damage. And this is the outcome. The left one is for the 475 years period, and the right side one is for the 2,475 years return period. the highest acceleration will occur around the Hawker area. And this is the peak ground velocity for both areas. This one is peak ground acceleration, and this one is peak ground velocity. And the deaggregation of the PSHA, as you can see here, I found that there will be 2 peaks here, 1, 2. Actually, there are 3 somewhere around here, but not very obvious like the 2 peaks. This one is correspond to magnitude 5.2 at the distance of 15 kilometers, and that one is correspond to magnitude 6.6 at the distance of 85 kilometers from the Adelaide CBD. And for the 2,475 years return period, the 2 peaks is become very obvious. And there are some evaluation of my outcome using several of here, like Rossiter in 1982, Gold et al., Malpass, Australian Standard in 1993, and the latest one is from the Leonard et al. At 2013. This is comparison my previous study and the right side with the Gaul in 1990. Gaul have different zoning, and my one only this 1, 2, 3 peak. This is the different. And this one comparison with the Malpass, most likely the same. Maybe because I use the data from the Malpass here. And this is the comparison with Australian Standard. And that one is comparison with the Leonard et al. In 2013. The left one is Leonard, and the right one is from my study. This one for 2,475 years return period. And if you see this, there is some strange thing that I found in my study at the Kangaroo Island. If you see my result that come out with high vulnerability or high PGA around here, and this area has no history of the strong earthquake around here. The strongest earthquake in Adelaide is about here. This something that I have to do more. Why it is in here and not in that part? And that's why from my preliminary probabilistic seismic hazard analysis, I have to extend the seismic catalog and then adjust the seismic source zone in the different scenario. This is my suggestion from my preliminary PSHA. And move to the next one, which is side effect. As I explained to you before, the side effect is important, and as you can see here, this is the recording of the Bara earthquake at the rock. The time history is like that, and what happened in the Regolith side? This kind of thing. This means we found that the time history at the Regolith side is higher than at the rock side. This is so that amplification is occur in Adelaide. And some bad example about amplification is this picture. This is from the Mexico earthquake in 1985, which is the building is sitting on the old lake bed deposit, and around that deposit has get a bad damage during the earthquake. Some that contribute to the parameter of site impact, which is impedance contrast, dumping of the material, basin topography, and the surface topography. And to show you that, to investigate that amplification is occur in Adelaide, not just only from the recording one, I also try to investigate using a site response analysis to see what is the spectral response spectral at the Adelaide regolith. There are two that I have done. First one is I using the actual ground motion, and the second one I use the synthetic ground motion. The actual ground motion I choose the Barra earthquake in 1997, which is the only strongest time histories that we have in Adelaide. And then I try also to see what is the outcome if I use the synthetic ground motion. This is the outline of the methodology. First one, to do the site response analysis. The first one is, and then the live site one is, we have to get the time histories, and at the same time we also develop the soil profile, how is the ground surface condition, and then moving forward until we put it into the model and see what the thing will come out. The site characteristic that I use for the preliminary site response analysis is from Selby 1984 and Collins et al. In 2006. This is the profile. I choose that place. This is from the government house just next to the North Terrace and King William Street. The profile will be look like that. And this is the street velocity profile at that government house. This is the only one that we have in Adelaide, only at the government house. And to simplify on the input, you can see at the front here, there are 8 different layers and the thickness and so on in there. It will be up to about 50 meter, I think more than that. And this is the actual ground motion that I will use, and the output is here, which you can see that the PGA at the government house will be in between about 0.17 until 0.21 G, and the response spectra maximum will be between 0.4 until 0.57, or in the 2 second, and the highest one is 0.71 until 0.79. This is the response spectra. The response spectra is when any earthquake occur, what is the event, the seismic event will hit the building. This is response spectra. Most of structural engineer will use this kind of data. And this is comparison with the others. If we compare with LOF, the present study is lower than LOF and PULOS, but higher than what Michel have in 2009. The spectral acceleration is less than law, but higher than Australian standard and Leonard et al. In 2013, which is only 0.12. And the preliminary site response using synthetic ground motion, I use the FISIM by Motazedian and Atkinson. There's an advantage here. The model is important to see a large earthquake at close distance. And this is the input for my synthetic ground motion, and this is the outcome. As I mentioned in the previous one, that we have at least 2 or 3 different scenarios. This is magnitude 5.2 at the distance of 15, and then another one is 6.6 at the distance of 85 and the deaggregation process. And this is the outcome of synthetic time storage from that scenario. And the pseudo-spectral analysis, if I compare with the island, this was my present study and this is from the island. It look like similar. And this is from another one. And this is from the last one, which is M6.6 at the distance 85. This is the pseudo-spectra. And when I put in all the synthetic time storage into the preliminary site response analysis, this is the outcome. PGA and the first scenario is about 0.2. Maximum response spectra is 0.646. And the last one is the PGA. And the last scenario is 0.03, and the maximum acceleration is 0.11. And this is the response spectra. As you can see here, you can see that magnitude 5.2 at the distance of 15 kilometers from Adelaide has produced the highest threat to the building sitting in the Adelaide regolith. And this is the comparison between pull-offs and so on, and we compare with the lob. My present study is low, and with Australian standard and Leonard is still higher. This is the response spectra from log and simplify of my present study and the red line. This comparison with Australian standard and Leonard in 2013. The conclusion of my preliminary set response analysis that is the input of motion of the area has been modified. This is due to side effect, and therefore further work to investigate the amplification of Adelaide regolith are required. And then move to the next step, that I will use another method that called as ambient noise measurement using SPAC method. The method is very useful to investigate the near surface geology, and the other thing is the method has advantage, is applicable in the urban area, which is this is because we are recording the passive noise. There is no any blasting and so on need to be done to do this test, and the penetration of the test also consider can up to about 100 meter deep. There is general consensus that I need to do here. I need to explain to you. What I will record is the micro thermal, not the microseism. This wave is induced by traffic, industry, and human activity, and the frequency, the phenomenal frequency is in between 0.5 until 1 Hz. And for this measurement, I will combine with SPEC method, which is the test need to be done in some special arrangement. I will show you later on. And this is widely used because to get data more reliable than just using the single measurement. This is the function from Aki in 1957, how to get the SPEC function using this equation in the model. And the methodology of my noise recording using SPEC method will be divided into two different kinds. The first one is the right side is the field noise measurement, and the left side is the conventional soil investigation. The conventional soil investigation is necessary because we need to know the general soil profile in the near surface before we interpret the survey profile from the ambient noise measurement. That is all the process that I need to do to get what is the survey profile in the near surface. And this is the equipment that I will use, the microthermal and the recording lungi. And that is the special arrangement that I already mentioned, which is each microthermal will be put in the hexagonal way, and that will record in the same time before we interpret what is the noise record in this equipment. And the distance is in between about 5 or 50 meters away in the circular array. This is 16 locations that tentatively I will use to do the noise measurement using the SPEC method. But maybe there are many across the city later on, because I need to get the detailed survey profile across the city. I will use a single measurement also, which is the area that is SPEC method is not possible to do because maybe the space is too confined or too small. The conclusion from this that at this moment is there is no noise measurement available in the literature from the regolith environment, and that's why I will do this also in my research. And the end, the seismic soil structure interaction, when I already have the profile, and then first thing is I will get what is the event earthquake that has possible contribute the highest possible damage from the city and the PSHA. After that, I will get what is the I need to transfer to generate from that scenario the synthetic strong motion that may occur, and then what is the profile of the near surface. I will use all the data into this soil structure interaction analysis, because when the seismic occur, the interaction between soil and structure will increase the displacement of the structure. This is the illustration how the soil structure interaction process. When earthquake occur, the seismic wave will travel hit the structure and some will going up and some will reflect back, and then the thing that going up will reflect back from the top of the structure and reflect up again, and some will go out in the soil. And the illustration of how the effect can be shown in this diagram, which is the total of the displacement is the sum of this. This is the ground, and that is the structure itself. Two different analyses for the soil structure analysis. One is the direct one, and the other one is the multi-step method. I will get more how to do these two methods when I already get some information about all the necessary input for this soil structure analysis. This is some sample, the finite element model of the structural system, how to model a structure and the building and the soil and foundation is. The methodology of my soil structure analysis, the first one is I have to know the typical near surface survey velocity profile, and then also I have to define what is the typical structure design building in Adelaide, and then the other one is to represent the free field seismic motion. This is from the generation of the synthetic ground motion, the input, and that one is from the ambient noise recording, and this one is I will try to see what is the typical structure in the Adelaide. Maybe I can divide into two different ones, modern building and the historical building, and then move on and come out with the result. My conclusion for the soil structure interaction is the SSI will cause the increase of overall displacement of the building, and I believe that soil structure interaction of Adelaide typical building is necessary to be carried out. And this is the progress to date and work plan. First one is the research proposal. Research proposal I have already finished, and for the M1, which is quantifying the Adelaide maximum considered earthquake, I already did the preliminary probabilistic seismic hazard analysis, and the draft of for conference paper I already finished, and abstract has been submitted and accepted in the Australian Earthquake Engineer Society, and the further work need to do is extend the seismic catalog and re-examine the PSHA. I expect that it will be completed on November this year. For the M2, which is generate the synthetic one, I already did I already generate the synthetic time histories and conduct preliminary site response analysis, but I have to refine that based to the previous result of the M1. But after we refine the first one, I will finalize my journal paper draft, which is the title is the synthesis of seismic risk analysis of Adelaide City and its implication. Final paper I expect to be completed on November this year. And for M3, which is measure and develop aggregate survey velocity, first one I just mentioned some important step only, conduct the trial and then single, and the second one is conduct the single measurement across the city, and the third one is to conduct 24 hours. This 24 hours measurement is important to see what noise that can be removed from the result in the second step, because you need to investigate. The recording for each one is about 30 minutes. Each location will be about 30 minutes, and I have to investigate the noise between day and time, because I will record across the city in different time. Then I will need to know what happened if I do the noise field recording in 24 hours and see what is the pattern. And for M4, I need to identify the input as before, and then construct the model and develop the evaluation for the SSI model. In my thesis, I will be finalized from January 2016 to June 2016. And this is the proposed paper that I need to write during my research. There are about 6 papers, and 1 abstract already accepted, two abstract already accepted, and the rest I will do later on during my progress of my research. Thank you.
Okay, time for questions.
You had return periods of 475 years and 2,475 years.
Yeah.
Why are they that long?
That is correspond to, for 475, this is correspond to 10% being exceeded of 50 years seismic event, and 247 years is correspond to 2% being exceeded for 50 years seismic event. And currently, the 500 years return period is commonly used. And but in the latest development during the expert meeting, I can say that maybe we have to extend, not just because some strange seismic occur in this recent moment, and then some experts suggest that maybe we have to extend, not just consider 10% being exceeded for seismic 50 years event, but maybe more than that. That's why we have to consider that.
Okay, yep, makes sense.
So the ambient noise measurement is really interesting that you are going to do. But my question is that what is the actually how are you going to use the results first, and then you are going to use the noise due to traffic, and let's say because there is no other sort of seismic vibration during the time. So you're going to use traffic only, yes?
Not just traffic.
Traffic and...
Yeah, this is like... The source is not just traffic, many things.
But for Adelaide, it's basically traffic and human. Because
I will record the microthermal. The microthermal is at this frequency. Yeah, this frequency is triggered by traffic and human activity here.
And you're using this for getting the soil profile?
Yeah, yeah. Based from the noise, and then see what the thing I will use like inverse algorithm to
Is
get
it natural
what is the
frequency?
profile.
Or natural frequency of the soil, something like that, or are you considering for that because you're using the same input as traffic, and you're going to extend this to seismic activity? Yes. You're getting the soil profile using some sort of input that you're getting from traffic, and then you're going to extend it to seismic activities, or let's say ground motions.
No. Okay. The survey velocity is very important to see how the dynamic characteristic of the soil. And then I need to know the survey velocity value of that particular soil layer. To get that, I will use the microthermor to inverse back how is the survey profile of that particular layer.
So you use it for different depths. Do you use this in different depths? Or
Different depth?
depths of the soil?
Oh, you mean go down? No. That is the advantages. One of the advantages of this kind of method. We no need to drill down and lower down the equipment. We just measure in the surface. In the surface. No logging, no boring, nothing. Just record what it is in the surface. One recommendation that I need to do, because this is based to the one project across Europe. That one, based to the project in the across Europe. To inverse that, we need to know first what is the actual profile. You mean this one will come out with only the soil type. This is in general soil type, like what it is the weathering, how much is the weathering, and so on. This is the profile, not the survey value. Okay, because if you want to do this with logging and geophysical logging, will be expensive, as I think it's not common in practice. Only special project only that they want to do that. They costly.
Okay.
As far as I know, Adelaide's is an interplay region, so there's not a lot of chance of earthquakes occurring, as far as what I'm concerned. But are you taking into account the probabilistic occurrence of earthquakes at all, or is it just you've run a Monte Carlo simulation and you pointed out a single point where, let's say, a magnitude of, I don't know, 5 on the Richter scale or something like this? Is that what you're doing? You're just to clarify, are you assuming an earthquake has occurred, or you're running what probable earthquakes would occur in the region?
Based to my preliminary result, yeah, that one. I already discussed with one of seismology expert that there is something wrong here in this part. We never have in our history a strong earthquake around this area, and we only have around here.
Yeah, that's not my question. I'm asking whether you're placing in earthquakes around that grid randomly using the Monte Carlo simulation,
Yeah.
and giving a range of possible earthquakes, or are you taking into account the probabilistic way of how earthquakes occur?
Yes, yes. This will be parameter A and B in the input. Yeah, that one. A and B is determined from the history.
Oh, that's what's okay.
And each zone. In each zone. Yeah, in every E zone.
And you just run one analysis for every
Yes.
every point. Yeah.
No, yeah, one analysis, you're right.
Yeah. Sure.
Yeah.
And,
So you had like where you're going to be doing all these tests with the microtremors throughout the Adelaide region. Could you just clarify or justify the positioning of all those tests? While you're doing microtremor
Yep.
tests, and you're doing that throughout the Adelaide region.
Not Adelaide region, Adelaide city.
Yeah, so the Adelaide city, like CBD region.
Yeah.
Right? Could you justify as to how you've got that like layout, or is you just chosen like a uniform distribution?
Yeah, this is hard to say because in the SPAC I have two different kinds, SPAC and single measurement. Actually, I will have a plan to grid the city, and do in every point. But some place is not possible to do using SPAC method. They need about a 50-meter area to clear the thing. And this is just tentatively. I define that some park is good place to do using SPAC method, but the rest maybe I found one interesting. If I found here and there is something wrong or something that need to explore more, I will do using the single measurement method to see what is the outcome, to refine the map.
Just one quick question. In terms of a lot of discussion about this spec meter or whatever you call it, if you've got an input parameter being the traffic or any other human activity, you'd have to know what that input parameter range would be, so you know that the output's going to be something, so it corresponds. Do you have to know what the input parameters would be?
No, no. But I will do refinement later on.
So does that mean you take it as being
No.
consistent?
Consistent or a range or distribution or something?
That one, the 24 hours is to see whether any something wrong with the input.
Okay, but if someone was running or like pounding something nearby, you'd definitely get a different recording than if something was in the middle of a park and no one went by it or no truck went by it. So how are you going to correlate that?
Yeah, that is the challenge.
Yeah.
That's why we have to understand what is the situational in everyday life around the area before I do the finalize the interpretation of the soil profile. That is the important step need to be aware. That's also the recommendation from the Europe project. We have to be aware how is the noise produced around that area. This need to understand that also.
Okay.
Yeah.
okay, is there any other? All right, so please join me to thank.
Okay.